My name is Peter Klar. I'm Professor of Experimental Physics at JLU, and I'm also in charge of the research campus area, Space Applications. Here at JLU, I've got two groups. One is working in materials science, and the other is working in space physics, in particular in electric propulsion. This is a rather big group with a long history, almost 60 years. We are working on electric propulsion. So that's especially ion thrusters, which are used on small satellites, but also for deep space missions.
My name is Chris Volkmar. I'm a professor for electric propulsion and electromagnetic compatibility at the University of Applied Sciences in Giessen. And together with our partner, Justus-Liebig-University, we are working in the field of space applications in the niche of the electric propulsion, where at THM I had the space electronics workgroup because we mainly look into the electronics part of the propulsion assemblies.
Well, within the Forschungscampus we've got about 15 senior scientists working in this field. It is a very wide field, so what we are addressing is questions essentially around satellite technology. That means the satellite tracking on the one hand, but it also means electronics development. It means the propulsion system, and all this needs to be brought together.
It's like a symbiotic system because they have all the experience and the infrastructure for testing electric propulsion when it comes to the thruster and the plasma and the plume, which is basically the ions extracted, and we have the knowledge and the abilities to build electronics which can forward its power to the thruster, and the thruster is supposed to use this power to generate the plasma, which is then in turn generated to a thrust which moves the satellite.
In particular, that means we need electrical engineering, we need physics, but we also need chemistry, because if one thinks of alternative propellants, there are very aggressive candidates. So we have to characterize the chemical reactions of the propellant with the thruster in space or under space conditions. We have to do material science. Develop new materials for space is also a hard and important task, so it's very interdisciplinary. Well, if you want to test something like a propulsion system on Earth, you need a little bit of space on Earth, and that means that we are running large vacuum facilities. We are running within the research campus about 10 vacuum chambers from medium large size to small size, which are either standard for standard tests with standard diagnostics, characterization of the thruster, but also specialized ones like our electromagnetic compatibility chambers, like this one we are here at the moment, and also special vacuum chambers where we can work with propellants other than noble gases, for example, for the air-breathing thrusters, which also need a different type of diagnostics. So it's many dedicated pieces of equipment plus standard pieces of equipment, which we also offer for cooperation with companies. So we've got lots of cooperations with space companies and also spin-ups, because we've got many test facilities they can use either in the context of research projects or in the context of industrial research services, which was a very good decision because we are running one of the largest facilities at a university in Europe.
Space flight or electric propulsion in particular is fairly new. That means there are lots of things to discover, and electric propulsion is also a very viable candidate for exploration of deep space. For example, the journey to Mars. This is actually the key for further investigating our known universe, actually.
we as a university or as a research campus, our task must be to look into the future and pave the way to new technologies and not to only address the current issues.